How Filament Lamps Affect Resistance by KayScience.com. Here is a simple series circuit containing a 3-volt cell, wires, and a filament lamp. The cell stores chemical energy, and the job of the cell is to push the electrons around the circuit. This flow of charge transfers electrical energy as they flow through the wire. I said before that this represents a filament lamp, and a filament lamp looks something like this. The red arrow is pointing to the filament in the bulb. This filament is designed so when electrical energy flows through the filament, the resistance is so high that the electrical energy is transferred into light energy and heat energy. So we can see, as the charge passes through the filament, the electrical energy is transferred into light and thermal energy. This is caused by high resistance of electrons colliding with the vibrating cations. These electrons then flow through the metal wire and back to the positive terminal of the cell. It's question time. Attempt these questions to check your understanding. We're now going to look at what happens to the metal filament to truly understand how metal filaments really affect resistance. So let's start with this close-up of the metal filament. These red circles with the crosses represent positive metal cations, and the movement lines around them show how the positive metal cations are vibrating. These blue E's with the arrows represent the electrons flowing through the metal wire. We can see how there is some resistance as the electrons do collide with the vibrating metal cations. Now, if the current increases in the metal filament, this means there will be more electrons flowing per second, shown by there being more electrons. Therefore, if there are more electrons flowing per second, this will cause there to be more collisions with the vibrating metal cations. So the resistance increases. So what happens next is, if the resistance increases, then the filament temperature increases as well. The diagram shows how there are more movement lines. This is due to the ions in the metal filament vibrating more. This occurs due to the temperature increasing in the metal filament. This diagram shows how the electrons collide more frequently with the vibrating metal cations. This is due to the positive metal cations vibrating a lot more as the temperature increases. So as the electrons collide more, this causes the electrical energy to be transferred into light and thermal energy, which is transferred into the surroundings. It's question time. Attempt these questions to check your understanding. We're now going to use a potential difference and current graph to understand how a filament lamp works. Initially, as the potential difference and current increases, they have a directly proportional relationship. This is due to the resistance being low and the temperature not increasing when the potential difference is low. However, as the potential difference continues to increase, the current does not increase at the same rate. This is due to the resistance increasing. If the potential difference is reversed, then the current and potential difference have the same relationship. It's just in the opposite direction. We can see from the graph that the potential difference and current are initially directly proportional when the resistance is low. When the potential difference is above 0.5 volts, the potential difference and current are not directly proportional. This occurs when the resistance is much higher, causing the temperature to increase. the ions vibrate more, the electrons collide more with the vibrating ions, and this extra resistance then causes the electrical energy to be transferred into light energy and some thermal energy. So, as the resistance changes depending on the potential difference, this means filament lamps are non-ohmic conductors. So, to summarize, only this part of the graph is directly proportional, whereas the rest of the graph is not directly proportional. Therefore, filament lamps are non-ohmic conductors. And as already stated, here we have reversed the potential difference, where the current then flows in the opposite direction. This has no effect on the shape of the graph. Pause the video here to practice the keywords. The answers will follow. Press pause to answer the questions. The answers will follow. If stuck, just rewatch the video. Press pause to go through your answers and make any corrections to your mistakes. And don't forget to visit KayScience.com for more videos, worksheets and quizzes at KayScience.com. And don't forget to like and subscribe.